Forget which model is the smartest. The number that decides what you can really run at home is sitting on your card. Most of the good ones simply will not load at all. They were built for machines you do not have, and your card just says no. Then somebody took a 27 billion parameter model and crushed it until it fit on that card anyway. That is the whole video. 5 memory brackets, 5 best picks, and the bracket almost everybody watching is actually sitting in comes first. So find your number first. On Windows, it is under Performance and Task Manager. On a Mac, it is your whole memory pool. Write it down. 5 brackets. The second one is where most of the people watching this land, and it is about to do something quite silly. Here is the problem. 27 billion parameters wants 54 gigabytes. Squeeze it hard and it still wants 9. Your card has 8. A team called Prism ML fixed that, and the way they did it is not normal quantization. It is something stranger. Normal quantization rounds the weights off and hopes. This retrained every single one of them, from the embeddings to the output head to be one of exactly 3 numbers, under 2 bits each all the way down. Nothing anywhere in that network gets to keep its full precision as an escape hatch. So the file goes from 54 gigabytes to under 6. The smallest build is under 4, which is smaller than a lot of browser caches, and it is the whole model. Put that next to a 2 billion parameter model at full precision, and the 27 billion one is still the smaller file on disk. Your gut says they must have destroyed it. They mostly did not. The bigger build keeps nearly 95% and maths barely moves. A 4-bit build does score higher, and it needs 17 gigabytes, so it is not in the running. Against the one that is, ternary wins twice. And it is quick, fast enough on a laptop chip to feel instant, and it still generates real text on a phone without falling over. That is the part that sounds made up. A 27 billion class model in a pocket doing tool calls and reading pictures. Free license, a huge context window, and it runs natively on both sides of the hardware fence. Prism ML calls this intelligence density, and it is the real story of the year. The box did not grow. If your number is smaller than 8, do not skip ahead. This rung got the strangest upgrade of the lot. The pick here comes from a lab called Nanbei Gu, and the whole trick is in what it chooses to do with the layers it already has. Instead of stacking more layers, it runs the ones it has more than once. You pay in time rather than memory, which is the right way around when memory is what you ran out of. And it works. On real GitHub issues fixed by an agent, it beats a 9 billion parameter model and a 12 billion one while being a fraction of the size of both. On a brutal graduate science exam, it scores what the flagship models were bragging about a year ago. On your laptop, so this is your workhorse, tagging, sorting, classifying, all the high volume jobs where a per token bill actually hurts. A long context window, no internet needed, and nothing you feed into it ever leaves the room. Bigger card, different answer. Up here, you stop compressing anything and just run the good one properly. And the good one is the model Bonsai was carved out of in the first place. Full precision, flagship level scores, and it finally fits with room left for a long context. There is a tax on these though, and you feel it in your bones. They think out loud before answering, sometimes for thousands of tokens, and every one of those is you, waiting. So, a small team shipped a fine-tune that does one narrow and very useful thing. Same model, same answers, and roughly half the rambling before them. On the benchmarks it was tuned for, it cuts more than half. Off them, it still cuts nearly half. The internet garbled this one. It is not smarter. It reaches the same score with far less rambling, which is what you feel. If you code against a local model all day and you are tired of watching it think, that pair is the move. Hey, don't forget to like and subscribe for more like this. Now, back to the video. Past 96 gigabytes, gaming cards are done. This bracket is defined by one specific little box, $4,000, 128 gigabytes of memory, and it sits under a monitor. Graphics cards at that price cannot load what this holds. The model built for exactly that box came from a San Francisco startup called Poolside, and its weights went up on Hugging Face on launch day. The trick here is sparsity. Most of that model sleeps through every single word you give it, and only a thin slice of it wakes up for each token. That is the whole reason it fits. On a test where an agent has to drive a real terminal, it beats a rival roughly 14 times its size. And on the harder one, that rival barely manages to score. And it is not just a chart. From an empty folder, it built a working browser engine in one unbroken run, then checked its own work against a real browser. Poolside says out loud where it still falls over, which is more than most labs manage. Almost nobody is up here. If you are, the reward is the best open weight model that is neither Chinese nor American. It is Korean, it is 314 billion parameters, and it was built from scratch rather than bolted onto somebody else's. 384 experts inside it, and 9 of them work on any given token. So it is a big brain that is genuinely cheap to run. And here's where it lands. On the closest thing this field has to a neutral scoreboard, it sits third among open models, behind 2 Chinese giants, many times its size. Quantize down, it lands around 300 gigabytes, which is squarely inside what 2 of those little boxes hold. And that is the whole point of open weights. Nobody can rate limit it, nobody can price hike it, nobody can delete it in an update. So that is the ladder, 5 brackets, 5 picks, and every single one of them runs on hardware that sits on a desk with no subscription attached and no per token bill at the end of the month. Now the catch, because this is not a sales pitch. The top of that table is still 18 points above the best thing that fits on a desk. So this is the best that you can own. It is not the best that exists, and pretending otherwise helps nobody. So how do you actually choose? Find the biggest model that fits your memory with a bit of room left over for context, and then run that one. It really is that boring. The real headline is not any single model on this list. It is that whatever fits your box today is dramatically better than what fit it 6 months ago. Getting one of these running is 1 install and 1 command. Ollama pulls the weights down for you and drops you straight into a prompt. Or there is LM Studio, which is the same idea wearing a friendly window with a search box and a download button. About 10 minutes, not a weekend. Find your bracket, pull the one that fits it, and then go and see what the hardware you already own can actually do. Honestly, it is probably going to surprise you. Go and find out tonight.